Hi, this is Ms. Sharada. Before you take your Module 1 assessment, I want to make sure that you can take these really long problems and apply all of the exponent rules in order to solve the problem. You will be asked to do this in the second part of your module assessment. So when you see a long problem like this, it can be overwhelming, but just take it step by step. First of all, you want to get rid of the parentheses, and to do that, you're going to distribute the exponent to everything in the parentheses. So, since this -2 does not have its own base, that means you're going to multiply the exponents together. So we're going to keep the base of 3, and 3 times -2 is -6. Keep the base of 4, and -5 times -2 is +10. Keep the base of 9, and 0 times -2 is 0. We're going to move on to the next set of parentheses and do the same thing. Distribute this power of 4 to each of those exponents. Now remember, this exponent does not have its own base, so you're multiplying the exponents. And you keep the base of 4, and -2 to the 4th power is -8. You keep the base of 3, and 4 to the 2nd power is 8. And over here we don't have any parentheses, so we keep that portion of the problem the same. Now, we want to get rid of our fraction now. So in order to get rid of our fraction, what we're going to do is, sorry, I'm trying to change colors of pens. We're going to take this exponent, this power and exponent, from the denominator, and we're going to move it to the numerator. Anytime we take something from a denominator and move it to the numerator, the base stays the same, but the exponent becomes negative. So now everything in this problem is a whole number. We no longer have any fractions. So I'm going to go ahead and write all of my numbers that I started with in one long line. So 3 to the -6th power, 4 to the 10th power, 9 to the 0 power, 4 to the -8th power. This became 3 to the -8th power, and 3 to the 14th power. Now we're going to combine like terms, and we combine like terms by finding all numbers that have the same base, and we add the exponents. So this 3 to the -6th, this 3 to the -8th, and the 3 to the 14th have the same base, and now we have to figure out the exponents. I have -6 and -8 would make -14 plus +14 equals 0. So when I combine all of these numbers with the same base, I get the exponent of 0. Once again, -6, like you owe somebody $6. -8, you owe somebody $8. Now you owe $14, and a +14, so you owe somebody $14, but you have $14, you would have 0 at the end of that. Next, we're going to look at all of our numbers with the base of 4. So we have 4 to the 10th power and 4 to the -8th power. So I have $10, but I owe somebody $8, so I end up with 4 to the 2nd power, because if I have $10, but I owe $8, I have $2 at the end of that. And this 9 to the 0 power has nothing to combine with, so it stays 9 to the 0 power. Now to solve this problem, I know 3 to the 0 power is 1, because any number to the 0 power is 1. 4 to the 2nd power, remember that means 4 times 4. 4 times 4 is 16. And 9 to the 0 power is 1, because anything to the 0 power is 1. So 1 times 16 times 1 equals 16. So this problem started out as a problem that looked very complex, but when I combined bases, that were similar or the same when I took the 3's and combined them together with their exponents, then combined the 4's with their exponents, and then the 9 didn't need any combining with anything, but when I did all that work, I came out with a very simple problem, 1 times 16 times 1, which gives me the final answer of 16. I hope that you do well on your test. I hope this makes sense. It's pretty late at night, so if something was unclear to you, please let me know, and I can certainly explain it to you again. Have a good evening.